Hi, grade sevens. I hope the thing with the strips today in class didn't distract you or confuse you in any way. What I was trying to do was give you a mental image of what happens when you take two fractions, two chunks of a whole, and put them together, even though the denominators differ. Sometimes it works out really well, sometimes it doesn't. But what I wanted you to do today was to take that same kind of mental image and see if you can apply it to what would happen if you subtracted two different fractions from each other, ones that didn't share the same denominator. Let's see if we can use the same way and figure it out from that point on. Okay, when we were doing addition, and I showed you this, and I'm going to use two very simple numbers to add together. I mean, numbers that you should be able to do off the top of your head anyway, but I want to give you an idea of what we're talking about. Say I wanted to add 1/2 and 3/5. Okay. Now, automatically, that shows the sum. It's 11/10, okay, which is the same thing as 1 1/10. But I'm going to take that away, okay, just for a second. These are two numbers that are really, really different, okay? In other words, 1/2 and 3/5, you can't, without playing with them a little bit, without actually taking a look at them and changing the denominator, you can't properly add them. So what I've done is I've changed the denominators. 5/10 is the same thing. In fact, I can put it right on top of it as 1/2. And 6/10 is the same thing, and I can put that right on top of it as there. So they're equivalent. Isn't that handy? Okay. So they're equivalent. There are other options. You could have 10/20ths or 12/20ths, and they would fit in the same places, right? You understand all that. But what happens when you're actually subtracting? Well, to do that, we got to do something a little bit different. I'm going to bring this down here, and I'm going to do this, and this, and this. Okay. For this, I'm not going to show sums or show equivalents. This is actually it's not the same kind of thing, but you'll get an idea. Let's say I didn't have 6/10, I had 3/5. And I want to take away 1/2. Okay, so let me get my 1/2. Now look at this. I've got 3/5, I want to take away 1/2. Okay, I can do that. What do I have left? If I take away the 1/2, what's left? What's this portion left that I've got remaining when I take it away? Well, it's not as clear as it should be if you take a look at it this way, because after all, 1/2 goes to here. There's no line to give you an idea. Here, it's sort of halfway through a fifth. So what if I were to take away the 3/5 and the 1/2 and put 5/10 up there, because that's what we're taking away, and it's exactly the same size, 5/10. And 6/10 is what I'm taking it away from. Now, can you tell me what 5/10 taken, what 1/2 taken away from 3/5 is? So you're working with equivalent fractions, right? So as soon as you work with those equivalent fractions, you're there. In fact, tell you what we can do is this. As long as I've got this here and this here, it becomes equivalent. So all I have to do is take this away, and you can see what subtraction will do. If I take 5/10 away from 6/10, what's missing is 1/10. So if I take 1/2 away from 3/5, it's still 1/10. Okay. Hope that makes sense, because now you're going to have to think about how to use that kind of number line thought to put together your answers. And what you'll be doing is taking a number line and breaking it up a few more times. I just don't have one that I could show you that's really nice and handy on screen. So give it a shot tonight. Go through it. See if you can figure it out for yourself. And we'll talk about it tomorrow in class. Good luck.